Hello everyone, we are going to see how to use array data type in R. First, select the R icon from your desktop window. So the latest version is available 4.0.3. It is released on October 10, 2020. So let us increase the size of the font. Okay, so we are going to create array. Array is a concept of creating the data in multi-dimensional. Vector is a concept of one-dimensional. Matrix is a concept of two-dimensional. So if it is more than two, you can create using the function array. Let us open the script. I already created the script for that one. So see this one, it's array. So before that you should know the concept of vector. So you see here, vector is nothing but the one-dimensional array. So you can create a vector using the function C, combine function. You combine all the data points and put it in a function name C. Okay, so you see I have created a variable vector, let us say VEC, that is equal to you combine all the data points, then the data points stored in vector. Okay, let us run this statement. Then you see here the vector of values. You can see the structure. You can see the structure of VEC. So it is a numeric. See, it's a numeric value. So numeric values are combined and put it in the variable VEC. So structure. So if we want to access the second value in that vector, you simply use square brackets. So you see here vector, in that vector access a second element, second position element. Suppose if you want to access the elements, you can extract the elements with the more than 50, which is greater than 50 from that vector, which is greater than 50, you can use this statement. So vector square bracket vector greater than 50. So greater than 50 values are extracted from the given vector. So likewise you can create a one-dimensional array. It is called one-dimensional array. Now we can create the two-dimensional array using the function matrix. For one-dimensional array using the function C. Here we are using the function matrix. From the matrix we can create a matrix using this function. So matrix is nothing but the combination of vectors, but it is in a homogeneous data type. Okay, so let us say we have the vector. What is the length of the vector? If you want, you can see the length of the vector. Just type a length of VEC. What is the length of the vector? See here, there are 12 data points are there. So now I am going to convert this 12 data point in the one-dimensional into two-dimensional array in the form of rows and columns. So you see, you take that vector values. Okay, using that combine function, you take that vector values, then create 4 columns. I am giving the instruction to create the data point, the 4 columns. Okay, so 4 column. Let us see how it works. So this is the variable name. Okay, see here. So you see 4 columns. So it automatically take the first 3 values in the first column, the second 3 values in the second column, and next 4 columns. So since you have the 12 data points that divided into 4, so that is nothing but then each column there are 3 data points. Okay, based on the given data points it took automatically and it created the matrix. What is the dimension of this matrix? What is the dimension of this matrix? You see here, the dimension of the matrix means number of rows then number of columns, 3 rows and 4 columns. It is the dimensions of the matrix. So you see here there is no title of the rows and the columns. If you want, you can give using the name column names of this row names within quotes, you can give the title for that. Okay, now you see, so your matrix, the row 1, row 2, row 3, column 1, column 2, column 3. Okay, so if you want to, you can create a vector directly using instead of giving column names, row names, you can give it directly here using the command dim names. So using the list function and the combine function, you need to use give the title R1, R2, R3, then C1, C2, C3. So this is also one kind of creating the matrix and giving the title of the rows and columns. Instead of giving separately, you can give within that matrix function, you can give using the function dimensions. Okay, so what is the content, the matrix content? So here C1, C2, C3. So if you want to access second row third element, it is 80, second row third element. So this is a index you can use to access the matrix values. So 2, 3 means first represents row, second represents column, second row, third column. What is the element second row, third column? So it is 80. Similarly, second row, if you put second, then it will display the entire content in the second row. Okay, so if you use that third one, so it is an error. Why it is an error? You use curly bracket, so don't use that curly bracket, use square bracket. Okay, so it means for the second subscript represents column, first subscript represents rows, so it display the third column. Okay, you check it, the third column. So what is third column element? 70, 80, 90. So it displays 70, 80, 90. 70 is in the first row, 80 in the second row, 90 is third row. But we have to press display third column values. So this is your third column value, 70, 80, 90. It is in the corresponding R1, R2, R3. Then one small computational part is there. You can use the apply statement to compute the sum, mean, some of the measurable function you can use here to compute the values. Okay, so sum, that means you need to compute the sum of the elements in that matrix. 1 represents row, 2 represents column. So for 1 represents row, that means what is the sum of the first row? It displayed 220. What is sum of the second row? 260. Sum of third row, 300. So if you use 2, then it column wise it will give the sum value. You see, the first column 60, second column 150, third column 240, fourth column 330. Likewise, you can use the apply function to find some of the statistical measure. 1 represents row, 2 represents column in that matrix. Okay, so next part, there is an array. It is more than 2 dimensions. So 1 dimension is vector using C function, 2 dimensions is a matrix using matrix function, then more than 2 dimensions you can use array concept using the array function. So I will take the same vector. So that vector contains 12 observations. You see the vector contains 12 observations. The 12 observation is created 3 rows and 4 columns. Okay, the same thing I can create a matrix using the array function. See the vector, I have created the matrix. I am going to create a array of matrices. You see, the first one represents row, second one represents column, third one represents number of matrices. Okay, so create two matrices which represents number of rows 2, number of columns 3. So 2 rows 3 columns. 2 rows 3 columns means the matrix contains 6 elements. Okay, so create 2 matrices. So 6 into 2, 12 elements are needed. So there are 12 elements is there in that vector. Okay, so you just pass the vector and create 2 rows 3 columns. So the row names are R1, R2, 3 columns C1, C2, C3. Then 2 matrices, I can give the matrix name matrix A, matrix B. Okay, so you pass the titles using the dim names. Now let us see the array, how it works. See here, so what is array here? The elements of the array. So it is a multi-dimensional rows, number of rows, number of columns, number of matrices. You see here 2 matrices are there. Actually, what is the elements? The number of elements is 12 elements, 10, 20, 30 first row, 40, 50, 60, 70. So 2 rows, 3 columns. Similarly, in the next 70, 80, 90, 70, 80, okay, then 90, 100, 110, 120. Okay, so number of columns, 3 columns. We have given 3 columns, 2 rows. Okay, so first 2 elements in the first column, second 2 elements in the second column, third 2 element in the third column, the first matrix. The second matrix 70, 80 is the first column, 90, 100 in the second column, 110, 120 is the third column. So the same vector we have created in the form of matrix, and also we have created in the form of array. So there are 2 matrices, okay, each has a dimension 2 rows and 3 columns. Now you see, so the first subscript rows, second subscript column, third one is the matrix name, the number of matrix. Okay, now you see, the one means it display the corresponding matrix, all the elements, display rows and columns in the first matrix. You are giving the instruction like that. Now you see the first matrix, it display the first matrix. What is 2? So it means rows. Okay, so it display the 2 rows, it display the second row of all the matrix. Okay, you see here, second row, the first matrix second row 20, 40, 60, second matrix second row 80, 100, 120, 80, 100, 120. So it display the second row and all the matrices. Similarly, what is this? 1 means the column, this is row, this is column, this is the matrix position. Then first matrix, second, we have created 2 matrices, so it is nothing but the index position of the matrix. So this is the index position of the column, it is the index position, index of rows, index of column, index of matrix. Okay, so this is the column. So you see here, it display the first column of 2 matrices, it display first column of 2 matrices, first column. So first column 10, 20, 70, 80, first matrix 10, 20, second matrix 70, 80, it displayed. So likewise, suppose if you click this one, so row, first matrix row, we see first matrix row 10, 30, 50. Similarly, if you want, you can get all the elements. So square bracket, use square bracket. So that means second row, second column in the 2 matrices. It's clear? Second row, second column is 40 in the first matrix, second row, second column is 100 in the second matrix. And also you can use the apply function also here also in that array. So in that array, so 1, that means the first 2 means the second one. Okay, we see here the first matrix row sum, first matrix row sum. Okay, this one is second matrix row sum, row wise sum, column wise sum, row wise sum, column wise sum, it will display. Okay, one represents rows, second represents the column. Okay, so in this way you can create multi-dimensional arrays. Okay, multi-dimensional. So here for creating univariate, use seek function. By rows and columns, that is 2-dimensional matrix function, 1-dimensional C function, 2-dimensional matrix function. For more than 2-dimensional, you can use array function. So in that array function, suppose if you are creating 3-dimension, you see here rows, columns, then number of matrices, like that. Okay, thank you.